I think most people have come back in, so we will restart. Okay. Good afternoon, and welcome back. I think we've had a very interesting set of talks so far, which has really shown the sort of interactions and interfaces between science and engineering and craft. So I introduced myself at the start. I am Ambrose Taylor. I'm an academic in the Department of Mechanical Engineering here at Imperial, and one of the reasons I enjoy this sort of environment is the problem-solving aspect and the application of science to things, basically. So the plan for this afternoon is just to finish off with a short panel discussion, and what we titled it as was Balancing Innovation and Craft. Do practical skills matter in the age of AI? Because what we've talked about so far has been very much on the practical side, people analysing, people and making as well, conserving. They're all very much practical skills, and I think that's the theme that's sort of joined everything together. But of course, what is happening, what you hear about on the news all the time is AI and the impact that it's going to have. So what we decided to do was end with a short panel discussion to consider that question. So what we'll do before we start, I'll just ask each of the panel members just to quickly introduce themselves in no particular order. Do you want to start?
Yes, I'm Pier Dragotti. I'm professor of signal processing here at Imperial College. What I do for a living, I look mostly at imaging for science and develop computational methods to extract information from the data. And just to make a couple of concrete examples, for example, I work with biologists to help them to extract information from microscope for structural biology, viruses, and so on and so forth. Neuroscientists to help them to extract neuronal activities from brains, again with microscopy. But also work with galleries, in particular the National Gallery, for the technical study of paintings. So they use various imaging techniques, similar to what was presented before by the Victoria and Albert Museum by Lucia, so XRF, HSI, and so on and so forth, and we try to develop automatic methods to extract some form of information. So I don't do AI, but something sort of close to that, okay? So we have algorithms that make automatic decisions based on the data.
Hi, I'm Lorraine Cornish. I work next door at the Natural History Museum, head of conservation. Look after around 80 million collection items, have an amazing team that I work with. I've been a conservator for around 40 years, I'm quite old, and I've worked for anything ranging from the blue whale skeleton that we see in our central hall to 2mm peacock spiders in alcohol, so a wide range, and I'm a big fan of AI, has to be said.
I'm Kat. I am the teaching lab manager for the chemistry department here at Imperial. And essentially what I do is try and teach undergraduate students how not to set themselves on fire in the chemistry lab.
That must be considered a very useful skill.
Yeah.
Yes. Okay. So what we're going to do is considering how the influence of AI on traditional craft science, etc. So we will start with the question, asking the panel members, and the plan is I will ask the panel members a bit of a discussion. After that, after about half an hour or so, we will open up the discussion to the rest of the audience. So we'll start by asking the panel members, how do you define practical skills in your field, and has the value of those skills shifted with the rise of AI? Who wants to start?
Why always me?
Go on.
Okay, so immediate answer
You're on the
is-
far end.
All right. So I'm an academic, so I don't do anything practical, right? I think that's the definition of academics, right? So, but okay, obviously we do a lot of teaching, and teaching involves preparation of materials, right, in the form of slides, lecture notes, exercises, coursework, and so on and so forth. So that's maybe one element. Then obviously the research side, in my case, is mostly computer related. And obviously we don't do math writing of code, right? The idea is that you do something very specialized, very unusual. So, but that's the practical thing we do, but also we help with some form of experiment, right? Either to build some hardware or going back to some of these imaging systems to help them to build these systems, right? So that's the practical element, okay, this experimental side. Obviously is in labs, in academia, so it's always related to something very unique, sort of, right? It's not mass production. We don't do that.
Lorraine?
So practical skills in conservation is really important, but also a whole range of skills, really, including cognitive. When we talk about practical skills, and I'm a natural history conservator, so it's slightly different in different disciplines. That's more of the sort of hands-on. So you're interacting with your specimens, with your objects, and you are using all of your senses, actually, to conserve, to condition report. It's very physical at times, but we also use a lot of cognitive skills, and so it's quite a mixture. At the moment, it's still valued, practical applications and practical skills. I know there's been some really interesting work around how practical skills in terms of being trained as conservators has got slightly less as the science has increased. So we have a much greater understanding now about our specimens and our objects and how they deteriorate and why, and that's brilliant. And sometimes it's just getting that balance between having the resources for the science versus the resources for the practical hands-on.
Well, my job is very practical. It's working in a chemistry lab, making things using chemistry. So there's a lot of pouring and weighing and moving things around. There's a lot of manual dexterity, as the conservation as well. There's a lot of similarities there. I was kind of thinking about this in ways that AI could potentially have an impact on how we teach. So in some ways, as processes in chemistry become sort of more automated, then I guess you're kind of shifting to your practical skills are then working out how to work with the automating machines. So that kind of is shifting more to a kind of engineering sort of side of it, I guess. Or in another way of thinking about it, if you stop teaching in a practical lab and you start teaching in a virtual lab, that's a different kind of way that you could potentially see a change. But again, then you would still need somebody to presumably program the virtual lab and come at it from that side. Personally, I think that that is not a thing that is likely to take over 100%, so there will still be the need for teaching those practical dexterity skills in the lab, and for technicians to be there who also need those to actually run the lab, prepare everything, make sure it's all running safely and so on.
Okay. Well, I am also an academic, and I used to work in the lab. I used to have practical skills. I think I've now probably lost those. I've sort of lost the dexterity and the knowledge of how the equipment works, etc. But I think for the sort of research work we do, a lot of it is a trial. It's the first time something's been done. We sort of saw from Simon's talk earlier that actually a lot of what we're doing is trying to do something in the lab that is unique, and that doesn't necessarily have the sort of knowledge that AI needs behind it to actually be able to predict that without actually going into the lab and making something, testing something and trying it out. Okay. So if we say there are practical skills that are still required, are there skills that you think cannot be replaced, or is AI and digitization going to have an effect on everything? I won't start with Pier Luigi this time. Kat, do you want to?
Yeah, I think a big part of what we're trying to impart to the students in the lab is learning how to work in a physical space like that, where you've got a lot of things going on, where there are safety implications if you are not working properly. Having that skill of working in that space together in a responsible manner. I don't know how this is again. I was thinking about what constitutes a practical skill, because that I feel like that's part of it. Is one of the things that we're trying to teach them. Is how to work in that physical space, and what we're trying to do in the labs as well is they get the academic knowledge from the lectures, from the workshops and so on, but they're actually seeing the phenomenon, that they're making a thing physically happen in front of them, that they can see it's tangible, they can touch it, they can smell it often, however much you'd like them not to. And I think that link between what they're learning, like cognitively, for all of their, from all their lectures and things, down to, well, actually, this is how what you've learned actually affects the world in a physical way. I think that link is something that you can't really replace with a virtual lab or with AI.
Lorraine?
Yeah, I mean, I think the whole idea of AI and machine learning has got such great potential for conservation. And in my world, because I'm quite selfish, I kind of feel I want to take away some of the more slightly repetitive, mundane things. So if I can get to a situation where I can have AI helping in terms of predicting degradation, being able to help me in terms of all of the surveys and the conditions, modelling what will happen over time, being able to help to control building environments, this is all great. I think the thing about, like, in terms of remedial conservation, where and especially if it's a 3D item, where you do need to interact with it physically, I don't think advanced robotics has got that far yet in terms of that refinement. And so there's always going to need to be that expertise and in real time and real world experience to be able to do that. So I kind of, there's a website you can go on which says, will robots take over my job? And for us, it's very low, apparently, so we can rest assured. But I do see there's a place for AI and for machine learning, and we in fact have informal coffee breaks at the museum once a month for anyone who's interested in anything to do with AI. You can go and you can talk, and we can look at how we're working on different things that involve AI, but there will always be, as a conservator, and if you're doing remedial work, you do need to interact with your objects. You need to be able to feel it. You need to be able to sometimes smell it. Sometimes people like to taste. I mean, I'm not like that. But it's understanding that, and also when you're going to work out what treatment you're going to use, you need to understand about the history of the item. You may not know, and you may have to do some extra research. There may be cultural reasons why you wouldn't treat an item in a certain way. Mm-hmm. It's a great puzzle to come to when we have a challenge in conservation and we've got to conserve something. We love to, we might look at it for ages and do quite a lot of work before we actually touch it. But that real-world expertise, I think, will always be needed.
Mm-hmm.
Yeah, so first of all, I would like to connect with the idea of dexterity. I think that's an interesting thing. So it goes back also to robotics. I think most of the very quick advances we are seeing in AI are software-oriented in some sense. Mm-hmm. Robotics is also making incredible advances, but probably not at that speed. And really, dexterity is something that we cannot do right with a robot. So if you're a gardener, I think you're safe. But I mean, there is that element there. Okay, here we can think of the future in various ways, right? But assuming that these AI, these agents are friendly, right? So they will be in the loop. And so obviously, in that sense, they are not going to take over jobs, but are actually going to help us, being more productive or faster in various things, okay? So that's a positive side, interpretation that we can have of AI in all type of forms, right? Obviously, clerical type of jobs are a little bit more at risk, so you'll have to do something a little bit higher level because AI is able to do something now, and so we need to operate a little bit at a higher level. If we go back to teaching in some sense, obviously we have a first challenge already, which is we cannot do coursework anymore as we used to do in the past, right? We have ChatGPT solving problems for us, so that's challenging us. In how we teach, right? In this case, in how we assess. Probably we're not challenged completely in how we teach, but also there we need to change maybe a little bit the way we do teaching because gradually, students will have access to tools to help them to learn more quickly maybe, right? And so that means that we need to think differently in the way what we teach, I don't know, the amount of information we want to deliver, and so on and so forth. So, but this is with AI in the loop, right, with the human being. So it's not really threatening us. It's kind of forcing us to change a little bit the way we do things, okay? And I make another quick example, programming, right? I mean, now we can have, this system producing software, right, for that. Mm-hmm. That doesn't mean that there won't be programmers anymore, right? There will be programmers that are good at using these tools so that they will become more efficient. So I don't see a complete threat like losing some jobs, but really that we change a little bit the way we do our jobs.
Mm-hmm. Yeah, I think at the moment a lot of the sort of I see conservation, and so there's a lot of analog information. It is the object. It's sort of information is not necessarily in a digital form, and what machine learning and so really requires a very big database to learn from. What was interesting was the talk earlier about cryptography. Was it 36% of digital information is fake? If we are using that to train AI software, if we're using that for machine learning, are we going to get a good result out if we can't rely on all the information we are training those models on? Do we actually need to be sort of filtering that information and carefully feeding in information? So I think that's one thing, and as I say, there's a lot of information that isn't necessarily in a digital form that can be used to build those models on. Okay, there's a lot of digitization work going on to get digital replicas of objects made available, but at the moment I think there's a little bit limited data to actually train those systems on. So we did touch on teaching there. Should we be looking for some sort of what should we be looking for in teaching? We have to teach some sort of level of digital competence, and we also have to teach some sort of practical skills. What sort of balance do you think there should be there? And I will start with the academic
right,
this time.
Yes. Okay. So right. So we certainly need to teach students to embrace new technologies. Okay. So that's for sure. We shouldn't be scared about that. And I mean, the other thing, okay, what we have to remember, schools or academia, right? We don't train people, right? We educate people, right? Mm-hmm. So educate means teaching people to become self-learners, to be critical, to find information by themselves, to look at patterns in chaotic environment. This is really what is education. And so if we use these tools to facilitate that, that's fine. Right? And obviously, we can make simple examples, okay? So calculators were discovered, right? I mean, we still learn the times tables, right?
Yeah.
So we think that, we don't need them if you want, right? Because we have the calculator, the simple one, now we have much more, right? But we think that that's a small tool which is important. Learning things by heart is still important. Small things, or the ability to, I don't know, do simple calculation when for some reason technology is not there. So it's not clear if we need to start selecting, topics, what we should maybe decide to remove completely, right? That's, I don't know, right? But certainly we want people to, keep these fundamental skills, right? So that allows them to, let's say, solve problems in different settings, okay?
I mean, your example about calculators, it's just what I was thinking as well. You used to have to calculate everything by hand when you're doing some analysis. You draw the graph by hand with pencil and paper. Now you just put it in the software and the program does it for you. We're already using like newer technology that we weren't using before. And AI's got a place in that, machine learning's got a place in that. It's something that we're already doing in the chemistry department as well in the undergrad teaching. We've got some courses that involve the students learning how to program the machine to do the machine learning as part of it. So they're kind of understanding, still getting that fundamental learning from it. They're just using the new tools that are becoming available as and when they become available to do that.
Right?
Yeah, no, definitely. I think there has to be that balance between the theory and the practice, doesn't it? And it's also around having digital competency and really understanding what that means and how you can best progress the sort of profession in terms of the scientific analysis and understanding. But also when you're actually working with real objects, what's the best way to treat them? You still need to use some of those considerations. And if it's all theoretical and there's no hands-on practice, as it were, then that means people become, I think, one of two things. They're either so risk averse that they don't want to touch something because they just don't feel confident, or they just think, oh, well, I've learnt this in theory, now I can just go and do that, and then possibly that could lead to issues. But I think it's about a collaboration, I think, really, between the practical skills and these and AI, machine learning, etc., and seeing looking at where you can both develop together, so you have a much better integrated approach. So I was really interested to read around the sort of the AlphaFold initiative, where they designed and are now able to design proteins and different structures of proteins, and that could have a really interesting application in terms of remedial conservation, material science. So that it's really understanding what the potential is as well as what we're actually doing now in real time. And I think there's a place for both.
So we've kind of got onto risks as well at this point. So we can certainly ask AI a question and we will get an answer back. Is there a risk of over-reliance on AI compared with human expertise? And of course, we've got some fairly critical fields here. We've got science, we've got engineering, we've got conservation. Anyone want to comment on the risks?
Everything's a risk. I mean, in an ideal world as a conservator, we would just have things locked away in very dark places with very stable environments, and no one would ever use them. And I think it was Jonathan Ashley Smith that actually described sometimes collections are almost in a waiting room. They're waiting to be discovered, they're waiting to be displayed, they're waiting to be studied. And for us, we really want to minimize the risk or lower the risk, but you can never completely eliminate it. And I think in terms of AI, so I put in a thing into ChatGPT around how to clean a fossil, and it was really interesting, of course, because that's a very general question. And so when it starts talking about things like wash it under a tap, use a toothbrush, because I know how to clean fossils and what the problems are, that made me feel a bit nervous, because if you don't have that expertise and understanding, you haven't really then got the judgment in terms of how much you can trust that data. obviously if you add more information in and more questions in, you'll get a more refined answer. But there is just that thing around making sure that you do have an understanding of the subject to be able to discern when perhaps AI is hallucinating or possibly giving you very bad advice.
I think where I see the probable risk of over-reliance, for one, is that kind of lack of creativity, because you only get out what you've put in the first place. There's no new creativity coming from it that you would get from people. But the other thing, I mean, you touched on it, like being too afraid to touch things. That's something that we noticed with the students who've come through after COVID. They didn't have the same practical experience in the labs in their schools that the students before had. They've all been at home in lockdowns. There's quite a drop in their confidence and their skills in the lab because they just didn't have that experience of actually physically doing the thing. Which, again, it comes up with the safety implications. If you are too afraid to do it, you don't do anything, or you get really nervous and you like shaking and you knock it all over and it all spills everywhere. Or, again, like you said, especially when you're in a chemistry lab, having someone who's overconfident and like, yeah, it's fine, I learned all about it, I know what to do, and then they just slosh it all over the place and you're just like, it's definitely somewhere that we've noticed that we really need to be getting that right level of confidence between respecting the various dangers of the things that they are using, but also not being so scared that they can't do it at all.
Yeah, there is a risk, obviously. So anything where we have a form of automatic decision. Now, most of our life, there is already a lot of software taking automatic decision for us. We are happy with that, right? It is true that in many cases there are some safeguards in place, okay, and especially if we think of engineering and so on and so forth. But the challenge, obviously, is that the more this system becomes sophisticated and the more we let them take decisions, right, the higher the risk, right? And also, the higher the risk is also because we start not understanding why a system makes a certain type of decision, right? Trying to predict what the system would do. So that is obviously the difficulty, right? I don't think we've found the right balance yet, right? Obviously, we're not at the stage, right? But obviously, we have situations where we let this, automatic system doing, more and more things. I mean, if we think of warfare, right? I mean, we're not affected by that, but obviously we have these drones moving around, making decisions, shooting, right? And that's done automatically, okay? And that's a huge implication. We don't really, And so that's one scenario. Obviously, we go in other scenarios, and the system becomes more and more sophisticated, and they do more and more things. We'll need to find a way to understand how to control, how to predict a bit better. So I think there is higher risk because things are getting more and more complicated than before.
Yeah, so I think there is always a risk, as you say, there is a risk in everything we do. The more we let that sort of decision making be taken out of our hands, then sort of the higher the risk. But also we don't know when models are built, what kind of data they're trained on, what sort of biases are built into that data and the decision making process that the software has. So I think it comes down to we still need that sort of expertise. We still need human experts to look at what's produced and make the final decision, which kind of comes back to what we were talking about, the sort of the human involvement, be it in the practical skills or in the decision making, and using the science, the analysis, and now AI as a tool to help us in that. At this point, I think what I'll do is I'll open it up to the audience because we
Yeah, we'll need a drink, won't we?
Yeah.
Now after that.
you have heard all of us talk. So I think if we open it up to the audience for any comments or questions.
Okay.
It is always the person in the far corner who puts their hand up first.
So I'm intrigued by how you chose the sort of juxtaposition between innovation and craft in the title for the session, because I think there's a little bit of an implication that maybe craft is not innovative by using it in juxtaposition to that word. So I'm just curious whether you think that's actually the case.
I think it's a case of trying to not make the title too long. Definitely not trying to imply that craft isn't innovative. You could argue that actually craft was one of the more innovative things, because there is kind of a freedom there. You saw from the last talk by Alex and David. That is, if you like, making something, and that was completely open to innovation there. So I think the sort of diagrams we have seen today to talk about sort of the intersection between craft, science, conservation. Those really a much better way of describing what is going on here. Anyone else want to comment?
Yeah, I mean, I see a huge overlap in terms of conservation and craft, really huge overlap. And I think it's really interesting to also think about the value of the things, the items that you're working on. And you sometimes need to use a lot of imagination and creativity in terms of how you're going to treat them. You need to understand how they were made in the first place, you know, or how they came to be about. And in terms of craft, you know, that is curiosity, problem solving. You don't always know, you can't always 100% predict what the outcome is. And a lot of that is exactly the same in conservation, actually. And so, you know, I think there's a huge overlap in between. And I think we can learn from both sides. And I'm always, you know, really interested in the crafts, as it were. And, yeah, I think they have a lot to teach us.
Okay. Yes? Okay, fine. Okay. Another question or comment?
It's been a long day.
Yes.
It's been a great day, hasn't it? Really good.
Any views on whether AI is going to affect your jobs? Simon, there is a microphone just behind you. Yes.
The point I would make is that AI is just another tool.
Mm-hmm.
And that, for example, in prototyping, you might go to AI and say, we're thinking of doing this, what do you think the outcomes will be? And it can tell you about how the materials might work and that sort of thing. But until you actually do the experiment,
Mm-hmm.
you don't know what the outcome's going to be. Or even you can ask AI, what do you think the outcome can be? But you won't know that outcome until you do the experiment. You've got to do the actual practical, is my feeling. Perhaps AI is cleverer than that, I don't know.
Mm-hmm. Yeah, so you definitely see a major role still for the sort of practical skills we've been talking about, and that prototyping needs to be done to test out ideas.
Absolutely, yeah, absolutely.
Okay.
I mean, there are, if I can,
Yeah,
I mean, there are discussions about automating experiments, even for discovery, right? So maybe to produce data, which would be useful then to do something new, etc., but also to reduce costs of experiments. I mean, sometimes, I don't know, you need an incredibly expensive, I don't know, a piece of equipment to do some experiments and so on and so forth. And so there are people thinking about having the entire loop handled by an AI system. How close we are to that, we don't know, right? I think the interesting question for us is that we tend to think that the human is in the loop, and we like that. The question is, with AI becoming more and more sophisticated, let's not use the term intelligence, right, is what is going to be our role, right? And I think that's an interesting, it's still an open question, right, to some extent. And okay, there are these pessimistic people saying that AI will completely take over us, and so we'll be run by them rather than the other way around. But if you think more like, you know, in the next 5 to 10 years, because this level of sophistication keeps increasing, we need to make an effort to stay on top in some sense. And I think people will be able to adapt, to understand these tools, etc., quickly, will be more efficient, they will be more successful. And I think that's a little bit the challenge for us. That's in my opinion, at all levels, right? Even for scientific discovery, etc.
Yeah. Okay. Thank you.
I think there's also, I'm just saying, there's also a backlash, isn't there, sometimes around nostalgia, and so you might have, you know, you can go on the bullet train in Japan, but actually people love to go on the steam train, and they love to keep that and preserve it and use it. So it's really interesting in terms of culture and how people respond to AI, and there's a kind of fear also, and I think for some institutions there's that worry about copyright, etc., and therefore, in fact, they're not necessarily putting the resource in to develop and understand AI in terms of how it could help them. So it's a conundrum sometimes, I think, for people. Sorry.
Okay, there was a
Yes.
comment or question.
Should I go
Sorry,
for?
yes.
Okay, I got the
Yeah.
microphone. Sorry. I do think that practical skills are important because obviously I think you've said it before with the question that you made of how to clean a fossil. That you need to have the practical knowledge to be able to make the right question and to refine that question. On another note, I was wondering whether, because obviously with all the pledges that we have to do on sustainability among the institution and also in a university, I guess, there's been lots of discussion of how AI has a big carbon footprint impact. And how do you see that evolving in some ways in the conversation of how much we can make use of it and how much then we can not do practical skills or replacing things that we're doing? Because obviously it could, like for example, condition reports, as you said, it would simplify work, it would make things more speedy, but with the idea that we have to be more sustainable, are we increasing carbon footprint in other areas by reducing our time in doing some things? I don't know, it's just putting...
Can I say something on
Yeah,
efficiency?
question.
I think that's a very good point. I mean, yeah, the footprints, etc. I think people are realizing that. I think the trend so far has been the bigger the better, right? And we have these big players, right? There's another issue of why we have these big players, why we let these companies to become so big. That's another open question. But obviously, these big players, they have the money, so they like to deliver the message. We are the only one that can do that. We have this super powerful system and so on and so forth. And obviously we had this recent news, this DeepSeek, etc. Without going too much into that, but then completely panic, right? But I think the message is that efficiency will be, I think, an interesting question for AI in the future for various reasons. It's not only for the good one, which is sustainability, but it's also about maybe I want my ChatGPT with my own data, right? And I don't want to share anything with anyone else, right? So there is this question there, right? So I think there is a room for creating more efficient system that you can control in some ways a little bit better for privacy reasons, for whatever reasons. And also, if we let only this company doing all these type of things, then we have two options. Either we don't use the technology because we don't have the money, or we just become user of that technology, right? And there is instead the questions of how we can adapt these big models, etc., to our own need, right? Maybe through some form of learning on that model and so on and so forth. So I think that's something that will be something that will emerge more and more, I think, in the near future.
Yeah, I think sustainability is a very good point, because quite a lot of what we've talked about today has been about sustainability, reducing energy demand for heating, ventilation, air conditioning, and yet AI, of course, is a huge user of energy and water, etc. So we're trying to reduce on one side, and yet on the other side we are effectively investing a huge amount of energy on the systems. There was another question or comment there.
Yes. So I was thinking about, like, if AI was to reduce maybe some of the grunt work or the big bulk sort of jobs we need to do, would we also perhaps lose some of the skills we gain along the way by doing repetitive looking? For example, doing condition assessments or surveys of large scale over hundreds of objects. Would we lose some of the observational skills we gain by doing that repetitive action?
I guess I'd say with 80 million collection items, I mean, this is just personal, but what I'd like is for the 10 million beetles, you know, maybe AI or machine learning could help that. The more complicated items or the ones that need more scrutiny, it would be nice to spend your time on those. But it is that, you've got to have that knowledge and understanding to be able to do that differentiation in the first place, haven't you? And sometimes it's really interesting to look at something that other people might find quite dull. And when we were working on the blue whale skeleton, for instance, you know, 230 whatever bones to it, cleaning and working bone after bone, condition checking, you know, there was excitement, but also it felt a bit mundane. But boy, by the end of that project, did you know and understand that skeleton? You just really knew so much more about it, and that expertise is really, really important to have.
Okay, I think in the interest of time. Oh, okay, go on. One more question.
Thank you. I was just going to make a couple of observations. One of them is entirely coincidental, which is the mention of the steam train and the bullet train. Having had a footplate experience last year, I would go for the steam train anytime. The other thing I was going to say was that I did something pretty ordinary but interesting at lunchtime, which was to extract one of those very delicious wraps from the tray. And I chose not to use the tongs, but to use my fingers. And I managed to extract it without touching any of the other wraps, and also without destroying the one that I was extracting. It wasn't very difficult to do because I've been equipped with this thing, which we've all evolved to have. I no doubt received an awful lot of feedback, visual feedback, sensory feedback, in order to achieve that thing, which I think would probably be very difficult to do using not necessarily just AI, but some computer-based system. It occurred to me that there are a number of things like this which could be achieved, and that perhaps fits into that point in the middle of the diagram that Kate showed this morning, which was initially magic and then became problem solving. And I think there will always be things which we can do fairly intuitively, which would be very difficult to do with some kind of computer-based system. And that just kind of comes back to that idea of, do practical skills still matter? We all use them, we will always continue to use them, but there's an interface between that and more mechanical skills, which I think will continue to be investigated, and probably very successfully so.
Okay. Thank you very much, and that was an excellent summary. So I will not try and improve on that. I will simply thank our panel and the speakers we've had today. We've had a really interesting series of talks. I would like to thank the organisers, IMSI, who you have seen around, and our AV people for looking after us so well. We've already had thanks to the catering team as well. So, and of course, thank you all for attending, for your questions, for your comments, etc. I would also like to thank the Science and Engineering Research Culture Heritage Network for supporting this event, which is one of the reasons we can make it free of charge to attend. There is a drinks reception outside in the concourse area. So if you have time, please stay and continue your conversations, and we hope to see you at future such events. Thank you very much.